Hello. This video is on geometric sequences in context, basically word problems. It's 9225. Despite what the top says, this is 9225. The reason why it's the same is we'll be using the same problems later for a different topic, as they're very similar. So after this, you'll be able to solve problems that are like this. You start with a certain amount of money, it goes up or down by a certain percent, and then how does that change over time? Alright, so let's start with an example. You buy a car that costs $19,000 and the loan has an annual interest rate of 3%. 3% a year is what that means, but it's compounded monthly, which means you get part of the interest assessed to you or billed to you every month. So, this is a geometric sequence. Reason why I know that is it multiplies by a certain number every time. Anytime you have interest, a percentage, that's multiplication. So, starting value, 19,000. Times the multiplier. Well, let me go back here. So the multiplier, when I have a car loan, I have to pay 100% of the money that I borrowed back. You borrow $19,000, you have to pay all that money back. Plus, you have to pay interest, which is extra. Basically, a fee that you pay to the bank for letting you borrow their money. Now, normally it would be 3% here, but this says compounded monthly, which means you're going to get part of this interest assessed every month. Now, the 3% is for the whole year, but you get a bill every month, so you're going to get part of that, or whatever that is divided by 12, every month. Alright, now what that adds up to is 100%, but then a little bit extra. What is it? 0.25. Now that is a decimal is 1.0025. So that is the geometric formula in explicit form that matches this. I'm going to skip the recursive form. If you don't make any payments, how much will you owe in a year? Just plug in 12 for, whoops, it should be n. Plug in 12 for n, and you'll get that amount. After exactly how many years will you owe that? You can't answer that exactly, but you can keep going down the line, guessing and checking, or typing it into your calculator and scrolling down until you see when it's 21,000. Another example. Alright, so this is actually the same situation. So the first part, about 19,000, the loan is 3% compounded monthly. You have the same equation. So you can get the same thing from that. You plug in, you see what you have. But the other part, the value of the car goes down by 13% a year. So that one will be a separate equation. Still starts at 19,000 because presumably the car would be worth what you paid for it. But the multiplier is going to be different. You start with 100% of the value of the car, but the value of the car goes down. We lose 13% a year. So what this ends up being is 87% as a decimal, 0.87. So if you ever want to know how much the car is worth, you plug in something for, oh my goodness, I did it again. Plug in for n, as that's the number of years in this case. Alright, go ahead and pause the video and try this on your own. Alright, let's go ahead and see how you did. Your equation for t of n, or t sub n, however you want to write it. If you did explicit, it should look like this. 121,000, and then times. The multiplier was 4%, but compounded monthly. Hopefully you remember to divide that out. And it ended up being 3's repeating. So that's the equation that matches that. The value of the condo is different. The value of the condo, hopefully it's worth what you paid for it, but then it goes up, and this is in years, so these aren't directly comparable here. The first one's in months, but that goes up by 5% a year, so that's why I did 1.05. Can you do these types of equations now? If you can, great. If not, watch the video again or do some practice in some other way.